Hello, everyone, and welcome to today's webinar with Ricky Smith and myself by the maintenance community. I will give us just 10-15 more seconds to let our final attendees trickle in before I launch into my little welcome spiel, and then we'll still see a few more friends joining. Ricky, you excited for this one today?
Oh yeah, fired up.
Wonderful. Well, we are just at 1 minute past the hour here, so I'm going to go ahead and get started. If you haven't joined us for a webinar before, welcome. We're so excited to have you here. My name is Heather Grant. I am one of the community admins for the maintenance community by Upkeep. If you are not already a member of the maintenance community Slack group, we would love to have you join us. We will be sure to add a link on how to sign up in the chat in just a moment. Today we have Ricky Smith joining us. Ricky is our maintenance expert in residence here at the maintenance community. That means he puts on one webinar just like this each week for all of our members totally free. Ricky, thank you so much for being here.
Thank you.
The recording from today's session, as well as the slides that you're seeing here, will be available in the maintenance community Slack tomorrow. Ricky is also available in the community Slack group to answer any questions live after the event today. If there's anyone else you know who would benefit from hearing more of Ricky's expertise, either from this presentation or generally, please feel free to send the replay of the webinar and the invitation to Slack to them as well. Final piece of housekeeping here before we get started, you'll notice that your cameras and microphones are not turned on today. So what you'll want to do if you have any questions for Ricky, or if you want to answer any questions that Ricky asked you, is you'll use that chat feature on the right-hand side of your screen here. We have a couple of people already saying hello in there, so feel free to say hello now or throw any questions that you have along the way in that chat box. We will have time at the end of our presentation to go through some questions and answers with Ricky, but please feel free to submit those questions throughout the presentation. Thank you once again for joining us today, and Ricky, I'll turn it over to you.
All right, thank you. Welcome everyone. Today we're going to talk about 10 things to know about maintenance best practices, and it's a topic that I love. So knowledge and known best practices is a requirement that will see the success of any maintenance organization. So best practices of maintenance and reliability are critical to success. So just give you a little introduction to me. University of Georgia, over 35 years, maintenance professional as a practitioner and consultant, working with companies all over the world. These are some of the companies, organizations I work for as a practitioner, not a consultant. So where did maintenance best practice originate? Well, as far as I can find out, the way to go back to is Alcoa Mount Holly. It was Alumax Mount Holly, established in 1975, had the first fully integrated CMMS in the world. We had proactive maintenance from day one, planning, scheduling, everything that you can imagine, maintenance engineering, it was in place at that time. I went to work there in 1980. So from a basic point of view, there's two maintenance approaches. One approach is reactive, the other is proactive. People say, well, we're kind of one or the other. No, you're either one or the other. You're not kind of a blend. You're either reactive or you're proactive. Just my thought. In practice, there are many combinations of these basic approaches. Reactive system responds to a work request or identified need, usually production identified, and depends on rapid response measures, if effective. How fast can you respond to a breakdown? I know it's important to respond to a breakdown, but it's crazy when you go to some places and everybody is reactive, everybody. The goals of this approach are to reduce response time to a minimum. The CMMS helps, and to reduce equipment downtime to an acceptable level. It may well incorporate what is termed as preventive maintenance program, and may use proactive technologies. So proactive approach responds to, so that was a reactive system. So the proactive approach responds primarily to equipment assessment. So what is the status of the equipment? Where is it at? And predictive procedures. The overwhelming majority of a corrective preventative modifications generally internally in the maintenance function as a result of inspections and predictive procedures. And the goal of this method are continuous improvement performed to establish specification, maintenance of productive capacity, and continuous improvement. Alumax of South Carolina or Alcoa practice the proactive method. So John said you're either proactive or reactive, one or the other. So here's this is a scorecard. Some of you may have seen this, but this when they were certified world class. They were Alumex when I was there, and then ultimately became Alcoa at world class maintenance. I guess they waited till I left, and then they got certified. So maintenance spending as a percent of replacement asset value. A typical organization can range anywhere from 5.5% up to 9%, but you notice world class maintenance is 2 to 2.5%, very low. Doesn't mean they're cutting their way to it. It means their equipment is reliable. Planners per tradesperson, 1 to 20, one planner to 20 craftsmen. Schedule compliance, so 90 to 100% for world-class maintenance. Percent of urgent, breakdowns was less than 10% of our work. PM accomplishment, very important, because predictive maintenance wasn't as common then as it is now. But 95 to 100% was world-class maintenance. So PMs were the critical factor of it. And then inventory turn, how fast does a part turn in the storeroom? So 2 to 4 times for world-class maintenance. And then maintenance training costs as a percent of total payroll dollars. It's the world-class maintenance. Most companies, I know this may be surprising to most of you, but most companies don't have a training budget, and the company may have a training budget, but maintenance doesn't. But world-class maintenance was above 6%. We went to training a lot. So it enhanced our ability to do a better job, and then for the company to reap rewards of that money they were spending on our training. So it's the maintenance best practices attributes. Rework is low. So this is the SMRP definition for it. So the metric is used, rework is used to identify and measure work that have the result of premature failures caused by errors in maintenance or operation of the equipment, materials, quality issues. Measuring rework, its root causes, enables plant management to develop and implement effective strategies designed to minimize or mitigate these errors. Typical strategies include maintenance training, operations training, defect parts elimination, maintenance procedures development or revision, operating procedure development and revision, improving purchasing and warehouse practices. So this came from SMRP metrics for those of you that are in SMRP. Wrench time is high. Wrench time is hands-on tool time, doing proactive work. Okay, so if you look at my chart down below, it says world-class wrench time, 55 to 65%. Typical wrench time is 12 to 25%. Why is typical wrench time so low? Because our direct work is low. We're looking for parts. We're waiting for coordination. We're waiting at the job site for a part, or we're traveling from one job to the other. There's a lot of things that go into it, but a lot of studies have been done on this. So typical wrench time, 15 to 25, world-class maintenance, 55 to 65%. So maintenance requires discipline, It requires discipline and execution of all work to specifications and planning and scheduling to ensure optimal wrench time through the use of repeatable procedures used to mitigate human-induced failure, and by executing preventive maintenance as a controlled experiment. What do I mean by controlled experiment? Preventive maintenance means we put equipment in a controlled state, because you can't do preventive maintenance on equipment that continues to break down. It's just not logical. But once you put it in a controlled state, you do certain things to it to keep it to whatever standard you want it to or need it to. Maintenance requires a scorecard. All personnel need to know how effective their team is at meeting targets and goals. They need to know the score in the area they impact. It's important for us as humans to know how well we're doing. It's like if you were to watch any type of game, whether it's football, soccer, rugby, whatever it is, if you don't know the score in the game, you don't get excited about it. Letting people have the score in the game is important. So scorecards and maintenance must be able to, measure efficiency and effectiveness and allow everyone to know their score. Now you notice here, this is actual scorecard from a company, a guy that was in my class recently. I saw it and I was like amazed. This is real time. This maintenance manager said he posted, once a week to give his maintenance people time to know what's going on. So you notice he's got best practice. That's their target of maintenance schedule performance, and schedule performance is schedule compliance. And you notice in October the 12th, he was at 62%, year-to-date 67%. Your maintenance break-in work, don't hear a lot of people talk about it. It means if it's scheduled for the day, but you got to break in on something, then it's called a break-in on work. So his was less than 15%, break into the schedule. So breaks to the schedule less than 15%. So year-to-date, he's at 33%. 10-12, he was at 38%. He said he was having some issues that, at the time. But at least he knew where he was at. PD and PDM work schedule. So schedule compliance greater than 30%. You notice year to date 35%, and then October 10-12, and then PM PDM compliance. Number 3, best practice knowledge and skill. Let me back up a minute. Hopefully you see this and notice that he's even got down to at the bottom, P1 notifications, SAP, polymer, equipment shift mechanics, how many he's got on. No information, P1 still open. So he has the things that he thinks are important to him. Okay. So number 3, best practice knowledge and skills. All personnel should be trained in known best practices, not what someone thinks, but what is known, what's best demonstrated, which are aligned and integrated. So maintenance best practices is part of that. Maintenance technician best practices, maintenance planning and scheduling best practices, maintenance storeroom best practices, preventive maintenance best practices, root cause analysis and triggers, and then repeatable procedures. So let me ask this. I'm gonna ask everyone, which one of these do you think are more important for you, the knowledge and skills? Is it maintenance best practices? Is it maintenance technician best practices, or what is it? Which one? Text it in. Or maybe repeatable procedures. How about that?
We got one that says planning and scheduling.
Good.
A couple more typing. Technician best practices, preventive maintenance. Another preventive maintenance, repeatable procedures, kind of some answers across the board here.
Good. You notice I put on a chart there, knowledge of maintenance best practices is a requirement for the success of any organization. That little picture I've got there, it's important, it's critical. CMMS must be fully functional and utilized. It's funny that I'm saying fully functional. I mean that all aspects of that CMMS are working. And very rare anymore do I go to the plants that are running bad. Typically, they're not using the CMMS. Why? There's a lot of reasons for it, but it needs to be fully functional, and we must use it. It means all work must be captured in that CMMS. So, CMMS setup according to ISO 14224. And that's, by the way, this ISO 14224 you see down to the far left. That's the equipment taxonomy. It's the collection and exchange of reliability maintenance data for equipment. How do you align that data in your CMMS? So not only can I find out what's going on with one asset, but maybe I've got similar problems across like assets too, all the way down to the equipment unit or even down to the maintainable level. Part typically in a taxonomy, you don't have that in there. CMMS users guide followed by everyone. So I like to have a CMMS users guide. So when people say, well, I don't quite understand what do I need to do to go in equipment history and find this, or, how do I write a work order or whatever, having a user's guide, especially when you have a new person coming in, it makes it much easier for them to understand how to use the CMMS that you're currently using. RACI chart created to ensure everyone knows their role in CMMS utilization. I think it's important for everybody to know their role. You notice in my chart below on roles and responsibility, I got CMMS data management, asset register, asset hierarchy on the task, asset criticality, data management, and so on. Across the top, I got CMMS administrator all the way over to plant manager. Defining roles and responsibility helps us work together toward a common goal, and that is to ensure we have the reliability we need because we're following the data and we're making decisions based on good data. Lagging KPIs posted for all to see, and they need to be difficult to manipulate. Otherwise, you may find this hard to believe, but sometimes people will manipulate the data. I want the data. If it's bad, it's bad. If it's good, it's good. I want to know what it is so I can feel good, feel confident that the data I'm showing to management is the right. And where does this data come from? It comes from closing out work orders accurately. Asset criticality, defect severity used to plan and schedule maintenance work. So when we plan and schedule maintenance work, when we say, okay, which one do we schedule first? Well, asset criticality, so how bad is the problem? And then defect severity, how bad is the defect or the problem with it? So asset criticality could be high, defect severity could be high. And that helps us understand which one, and I've seen software programs where it had an algorithm in it that as soon as it saw that asset, they knew the criticality up with defect severity up, and you got multiple work orders, it can rank them for you very quickly. And you can put in the human approach to it too, after that. But at least give me an 80% solution when I'm going to plan and schedule work. All maintenance work is charged to a work order, which is charged to an asset. Work orders don't do me any good. I know it may surprise you. There are a lot of companies out there to use blanket work orders to cover. Okay, if we don't really have, when to charge everything to that asset. So we just write a blanket work order and everybody, whatever maintenance work you do today, charge it to that work order number. No, I want it charged to the asset. Maintenance process maps are followed. So I want to ask you this. How many of you have process maps for maintenance, for like preventive maintenance, predictive maintenance, planning and scheduling, work execution, and so on? Say yes or no.
Couple of no's so far. Couple more no's. Another no. Any yeses out there?
Come on now.
Oh, we got one yes.
All right. I got the spirit up now.
Somebody said some.
All right.
Yeah.
So sounds like that most people don't have process maps. I tell you, I mean, to say how we're going to repeat something over and over again without having to process, need to have a high level. So here we got PM, PDM inspection, maintenance planning, maintenance scheduling, work execution, work order closeout, and then failure reporting. If we have failures, we can go back and improve our PM, PDM program. I just made this one real simple, not complicated. Work identification, maintenance planning. Here's the maintenance scheduling process. So every one of these should go down to a lower one that actually takes up our scheduling process. So this is the maintenance scheduling process map. Work order closeout. What does that look like? Storage parts process. How do we check out parts? There should be a process map. Doesn't have to be complicated. If you're looking for some, there's plenty of them on the internet. The best thing to do is, if you don't have one, keep it simple. Just start from step one all the way through to the last step. Okay. Failure reporting, analysis, and corrective action system. Process maps are critical. Otherwise, we're lost. It's like not having, any kind of map to tell us that, are we on track or not? Number 6, conducting a PM optimization. PM optimization is a big deal. So first, with PM optimization, we identify asset of functional areas. The PM optimization will be executed. You notice that this one here has got one production area. Identify a cross-functional team. I like having an operator. Why an operator needs to be in there for PM optimization? Because they may know something we don't know. Maintenance technician, reliability engineer. I want the maintenance planner in there. Establish expectations from everyone engaged in this process. Tell you what, I love it when you do this, because when you first get in there, you wouldn't be surprised how many people have no idea why we're doing the process. But once you get into it, especially like you get an operator. Operator like, wow, yeah, I'm glad we're doing this now. It's amazing. Define the end goal. What's the end goal going to look like? The end goal is we don't have the breakdowns we've been having. So we want to reduce breakdowns by this, emergency labor hours by this. OEE goes up. Define how you measure if PM optimization is effective or not. If you've collected data before, you got data after, especially your metrics, it helps you a lot. I can tell you in this place, on this specific one I was talking about that I did a while back, the OEE on this line went up 12%. So pretty significant. Present copies of PMs to all parties. Review equipment history. So the last 30, 60, 180 days. I want to know the number of breakdowns, the cause of the critical breakdowns based on formal RCA. And I want PM labor hours versus emergency labor hours, because that may tell me I may have a problem with my PM program if this emergency urgent labor hours are a problem. And one of the things also could be to tell people preventive maintenance. It's insanity performing preventive maintenance on equipment that continues to break down. It's like having you're going to do PM on equipment and the equipment breaks down all the time. Is that logical or not? No, it's not logical. If we have preventive maintenance and it's working, we should not have the failures. That's why I like emergency urgent labor hours. Review current PMs and PDMs to identify the PM procedure may need to be rewritten. Maybe it's good, but it's too lengthy, or doesn't make a lot of sense. But so we can make it, very simple. I like steps in a PM procedure to be no more than a noun, adjective, and a verb. I don't check chain drive. Okay. So what specifications I check the chain drive? Okay. This training which may be required. So as we review the PM, the PDM, we may need to have some training on some of that. PM frequency may be inaccurate, may need to be adjusted. If the equipment is in a maintainable condition, I want to know if the equipment is not maintainable condition, is breaking down all the time. We call it insanity. Performing preventive maintenance on equipment that continues to break down. Rewrite PMs or write new PMs. So it depends. Yeah, we need that PM, but it's not quite accurate. So we need to rewrite that PM to make it more accurate. Or maybe we don't have a PM, on that one component or one asset or whatever. So we have to write a new one. Monitor and measure to ensure new PMs and modified PMs are effective. We got to measure it and then we got to monitor it. So results from PM optimization, here's some of them. PM. So across the top, we got PM evaluation recommendation on the vertical. The next vertical, we got the number of tasks that we evaluated. So task means if you got 5 tasks on that PM, then that would be 5 in the number of tasks. And then what percentage added no value, delete tasks, and then labor hours for it. So here we got no value added. Okay, we got 1,740 tasks. The percentage of total tasks had no value was 15%. Labor hours represented, look at it, 1,800 labor hours. We're spending time performing preventive maintenance on it, and we really don't need to because it has no value. Reassign the lube route. Look at this. So when we say reassign the lube route, one of the things that I found, and I'm not going to mention the country I went to, but I'll tell you, it's in Malaysia. When I was in Malaysia, this one company, their top level paid technician was a lubricator. I said, what? You pay a lubricator more than anybody else? Yeah, because I want my most experienced person when they go in the lube route to not just lubricate correctly with this hydraulic fluid, what is lubrication fluid, or what is grease or whatever. I want that to be the most competent person. Wow, it shocked me. So what do you think about maybe assigning a maintenance technician? All they do is do the lubrication. If you got a lot of lubrication, why not? Get them trained and all that. Reassign operator care. Why is a maintenance person going by the same thing the operator looks at every day? I like putting little targets on things for the operator. 1, 2, 3. That way they can see those and they can focus in on, say, okay, what do you see? And on point 1, I see smoke. I smell something, whatever, Replace with PDM. A lot of times we're doing a lot of PM. If we hire a PDM company or we do it ourselves, PDM, there are some tasks that we do for inspection that the PDM is going to be at the equipment. Why don't they taking infrared or whatever, why don't they add those inspections to their list rather than it being somewhere else? Rewrite task. It's a good task, but we need to rewrite it so it makes more sense and it has more information. Maybe we need specifications on it. Task as good as found. Okay, so that's 20% of the total task. That's labor hour 3,923 hours. When we actually take this PM optimization, we're finding that we've got more people freed up to do other things because we've ensured our PM program is effective. Okay, so the number of tasks. Number 7, mitigating failures 101. First step in mitigating failures, we got to have good work order data. Needs to be closed out by the maintenance planner. I know some of you starting to move around your seat a little bit now, saying, well, the maintenance supervisor does that. I think, I was a maintenance supervisor. I have to tell you, I wanted to look at the work orders before I give it to my planner. When at the end of the day, I looked at all the work orders, and if everything looked good, then I'd pass it on to the planner. I might put some notes on it or something, but the planner should be the last one to close the work order out. Why? Because they're sitting in a calm state. Okay, their hair shouldn't be on fire. Like if you want to know if you got a proactive planner, tomorrow when you go back to work, call them on the phone, say, hey, I need a part right now. And if the next thing you hear is a dial tone, you got a proactive planner, because they don't get involved in today's work. They're working on future work. So they're the ones that, as calm, can close out the work order and make sure all the data is accurate. Asset number, when to make sure the asset number is right. Asset criticality, downtime costs. If we can capture that, I think that's good because it tells us a lot. Downtime in hours and minutes. Maintenance labor hours estimated at planned and scheduled. Maintenance labor hours actual. So estimated versus actual. Parts are charged to an asset. All parts must be charged to an asset. Measure and manage failure through accurate data collection from closed out work orders. Identify asset or assets with the highest number of failures and maintenance labor hours. I tell you, if you look at all your assets, and you say, okay, let's say I've got 100 assets, but my assets that have the most emergency labor hours or urgent labor hours are these assets, then I probably need to focus on them with my strategy to figure out what's going on. Creating a standing team, a FAT team. FAT team's a failure analysis team consisting of maintenance techs, reliability engineer, production personnel, maintenance planner, storeroom manager. You decide on your teams, who's going to be on there to mitigate failures. Define the end state. Maybe it's production now is running at rate. The OEE is at 90% plus. That's what we've been wanting them to be, but we never have been there. Or maybe we got there a couple of times last year. So when I talked about those teams, so mitigating failures with teams, here are the teams. Okay, so we got the FAT teams monthly. All right, cross-functional standing team, meeting monthly, led by maintenance or reliability engineer. Review equipment with the highest number of unplanned work orders, hours, and costs, and then take action to prevent recurrence of failure. And then we got our ERT team, equipment reliability team, based on triggers set by specific KPI. So we have a cross-functional ad hoc team. Ad hoc teams means we just call it when we need it. Okay, we don't have it all the time. Failure analysis team is we have it every month. Okay, led by a reliability designee. It doesn't have to be a reliability engineer. It could be a smart maintenance tech. Focus on one equipment system. Use RCA to identify the root causes of it so we can mitigate them. Then process reliability team, the PERT team, based on triggers set by specific KPIs also as the previous one. It's the same thing. It's cross-functional team meeting, co-led by maintenance reliability engineer on this one. And because this is process reliability, we want maintenance and reliability engineer and the production designee together, co-led this team. Focus on reducing process functional failure. You may be surprised, probably going to shock all of you when I tell you this, but production has more losses than we have in maintenance, and a lot of people don't believe that, but a lot of analysis I've seen over the years used to work on process viable plots on companies. It was amazing how much money you're losing, because of production, not operating the equipment to specification, not starting up on time, having too many breaks, break-ins to their production, if it's minor things, slow speed, whatever. That's why I like OEE. Use RCA to identify the root causes. Okay. Then the PM optimization team based on triggers set, for specific lagging indicators. So on the pot team, I know some of you may, find that kind of humorous, but it is true. Okay. I see the company had a pot team. Okay. People thought it was funny, and it got people thinking about it. That was what I liked about that. These are based on specific lagging indicators. Cross-functional team meeting, focus on assets not meeting production, requirements. Perform RCA, identify causes and remedies. And PM is not meeting expectations. Make decisions based on the PM dashboard. You see the dashboard below. PM compliance, number of breaks of the schedule, PM PDM yield. So how many things do we find out of the PM? How often we go back to an asset do we see a problem? Typically, when you're doing preventive maintenance, you should go, anywhere from 3 to 5 times without seeing something. If you see something every time, then your frequency may be either too far out or the equipment is not in a maintainable condition. So having a number there to identify that's a big deal. So breaks to the schedule, PM, PDM yield, PM overdue, PM's evaluated 0 on there, PM's optimized 7, emergency urgent labor hours 234, PM labor hours 48, PM cost, then OEE. You notice that 4 of them are SMRP metrics. All right. So number 9. Be aware how reactivity begins in proactive maintenance. New leadership, effective maintenance dashboards make it hard to make changes. If you have an effective dashboard and someone comes in as a new leader, then it's hard for them to make changes to it if we have, a dashboard. Complacency, never be complacent. Always be looking to improve every day. That's something that was pushed to me by John Day at Alcoa. He always told us every day you should learn something new every day. No maintenance, scorecard posted for all to see. Post a scorecard. If you don't have one, start one. Post a scorecard in the maintenance shop. Begin each day. That's what I used to do, my guys. I didn't have anything jazzed up as this, okay? Be honest with you. But we talked about the data. Where are we? Where are we at in maintenance right now? So on this one, and this is a 5-minute huddle. That's what I used to do with my guy. 5 minutes. That was it. So PM compliance. Hey guys, we got to do something about this. Okay. What is the problem? We need to solve this problem. Emergency urgent labor hours are going up. OEE is 68%. Safety index, incident rate index is 5.7. Storeroom stockouts is 13. Budget compliance 44%. We got a problem on this one. 5-minute huddle. So 10, weekly education, toolbox training. All right. Weekly meeting. This typically is 15 minutes. Maintenance supervisor hosts a meeting. Okay. Focus on a topic which needs to be discussed. This is one of them that I created called How Do Bearings Fail Part 1. I have a Part 2 was on that also. So this one, bearing failures are increasing. Give everyone a copy of Toolbox Talk. Okay. And I'd post one in the shop first, what I like to do a few days ahead of time so people start looking at it and reading it. And then typically mine was on a Thursday. So Thursday we'd have a meeting. And then I'd say, okay, what did we learn on that Toolbox Talk this week? Do we need to go over it? Tell me, So I asked the question, stimulate knowledge sharing. It could be an example like, okay, because everybody's sitting there going, oh my gosh, this is boring. So ask them a question. Which one of the causes of bearing failures have you seen? Okay. So they see what I'm doing is I'm trying to pull them in. So they look at it and like, where? Maybe that's one. Where is a failure mode? Okay, for a bearing. So contamination, lack of cleanliness before and during mounting operation. Use SKF bearing mounting gloves, keep area clean. So what I'm trying to stimulate a conversation is what I'm trying to do. I'm trying to take my people to the next level. So what I do is when I post this, we discuss it, then I'll leave it up there to the following week so everybody can review it. So people will walk by and review these things, and it helps share knowledge with them to make them better. All right. So questions. These are 3 upcoming workshops coming up. So what are your questions?
Thank you, Ricky. That was awesome. Didn't see any questions come through throughout the presentation, but if anyone has any questions to submit now, please go ahead and do so in the chat.
One thing you learned today, one thing.
Yeah, that's a great idea. Ricky, which of the 10 is the most important?
Say that again?
Which of the 10 maintenance and reliability best practices that you shared here today are the most important?
I would say it has to be preventive maintenance. I mean, that and planning and scheduling, those two are really, really neck and neck.
Yeah.
That's why I always say, in the process of maintenance, we have certain steps. If a step is skipped of a formula substandard level, it creates defects known as failures. So we have to have, I start with one. Let's just say preventive maintenance best practice. That's a big one. If you think your PM program is not providing the results you want, that's where I would start. If it's planning and scheduling, wrench time is low, hands-on tool time, then you probably need to work on that. And if best practice is overall, then that's where I start at. Sometimes just picking one will work. It'll feed the other ones. Anybody else?
Ricky, could you flip back to number 7 so that an attendee here can have a look?
Right there?
7. There we go. Yep. Sorry, it was just a lag on my screen. Mauricio, go ahead and look at that slide. Let us know if you have any specific questions on that. In the meantime, we do have another question that's, how can we perfectly measure wrench time?
They used to have a wrench time, PDA that you could use, but measure wrench time anymore. The biggest thing you can say is that if you would just take observations, okay, it's the way a PDA works. So when you do you walk around and you observe people, so observe what they're doing. What percentage of what you observe is proactive? What percentage is they're looking for parts, so they're traveling from point A to point B. I talk about this in the PM optimization class or PM best practices class. It's amazing how people, they go out to the job. Man, I forgot a tool. I got to go back. So there's a lot of things that fall into it. I would say I like having these teams that I talked about, mitigating failures. I like these, having a team, and it's set up at a certain time. It's based on certain criteria. I got someone leading that team, so it's just a thought. Okay. All right. What else?
What's the best practice in your experience to improve productivity on a maintenance team?
Maintenance planning and scheduling. Maintenance planning and scheduling will make all the difference in the world. Because in most companies, wrench time is low. Hands-on tool time doing proactive work is low. That one thing will make a serious impact for you.
Great answer. Thank you.
That it?
That is it right now. We have one more person typing. We'll see if it comes out as a question or just another statement here. Just a moment. Oh, we have 2 more typing now.
What do you guys think about the PM optimization? The process and the results. Because if I can optimize my PM and I've got less labor hours on PM and they're effective, then I can reassign them to something else. I can have, because other people around that could do this. But typically the PM evaluation, we only have a small percentage that are deleted.
Waiting on some answers to that.
What is that now?
Just waiting on an answer to that.
Answer to what?
to your questions about preventive maintenance.
Okay.
Yeah. We have a separate question here, but I'll save it for just one more second. How can we do a good PM optimization if data collection is not accurate?
Let me go back to it, and we'll talk about that. That's a great question. The PM evaluation. Let's just think about it. Okay, so let's say we don't have good data. Okay, so but why are we doing a PM optimization? Is there some maybe we feel like the equipment's not running the specification or something? There's something there that's causing us to do a PM optimization. Okay, so in this case, in this plant, that it was a board plant, the last one I worked on, and we actually took the board plant. We took one section of the board plant and we focused in on it. They didn't necessarily, they weren't sure which area was the problem. That's what they had, because they didn't have good data. So what we did, we started going through the PMs. We just went through a few randomly. We just pulled some PMs and went through them. And my gosh, I mean, out of those PMs, it was very little PMs that were really good PMs, because it was too lengthy. Maintenance person's not going to read 3 lines of information. Okay, so we needed to break that out. The other thing was that we found that we were having a lot of breakdowns, but they weren't tracking the data good enough. But the maintenance technicians knew it. I mean, they know what's going on. I just asked the technician, which one do we start with? Okay, and that's where I start. If you don't have good procedures, maybe you just start writing procedures on one asset. I mean, if you got asset criticality, go with the most critical assets. If you don't, say, hey, let's go focus on the first one. Now, understand preventive maintenance. You can't perform preventive maintenance on equipment that continues to break down. Think about that. It's not logical. It's not logical. So we got to bring, if equipment will perform preventive maintenance on continues to fail, even with PM, then we need to go in and identify all the problems with that asset and bring it up to a maintainable level, and now put PM on it and do it the right way. It's like that, your 62 Chevrolet or 60 or 59 Mercedes or whatever, it doesn't run very well. I'm lucky to make it to the store. I don't drive it to work anymore because it's so broke. I mean, if we restore it, then we can maintain it. We don't have to restore it all at one time. We start out with the biggest problem first. So we got to have a good PM program on it. All right. Who else?
When maintenance technicians leave comments about a completed job in the CMMS, it's a free text form, and it gets pretty messy because every shift tends to write their own way. Is there any kind of industry standard that you know of for commenting in CMMS systems?
I've seen a few companies that they have codes in there, because there's so many things I put in there. So they have codes. A lot of times that free text I want in there helps me determine whether I need to write another work order to the plan and schedule. So a lot of times in that free text, I'd like to know if there's something they see that we need to do something about. Free text is good.
Awesome.
Yeah. Did I answer your question?
That was from Andre. Andre, was that a good answer? I have another question here. How do you go from reactive to preventive when reactive is the norm?
If reactive is the norm, you got to pick and choose. Where do I start? And sometimes when you're reactive, you got to start somewhere. Okay. So what I do is I focus in, just like this PM optimization. I'll pick one area. So that one we're going to write procedures with. We're going to have good PMs on it, and then we're going to manage it. So I call it proof of concept. Once we prove that we can bring equipment up to a reliable state, then from then on, we're going to have PMs and PDMs on it to give us the end result repeatedly over and over again. But that's our controlled experiment. So that's why this whole line is like I've got here. You can do the same thing here. Focus on that one asset or assets or line. Focus on it. Keep doing what you're always doing everywhere else. On this one, we're going to focus on it. And when I seen it one plant, I was at. Now I didn't create this, but the maintenance manager came up with this. But we brought the equipment up to maintainable level, Okay, that means we inspected everything, found all the problems, and they repaired it over a period of 6 months. I came back and I'm like, what is that sign up there for? And they had a sign on the line that says, warning, maintainable equipment, no reactive maintenance authorized in this area. I thought that was pretty cool. I said, why do you do that? He said, so I get people's attention. I don't want you to come over here with a hammer and beat on a machine when you know you should be using the right tool. And I'll tell you what, it went through the plant like wildfire. It was great because he went to the next equipment and next equipment. It worked out very well.
Love that. Awesome. Well, that's all the questions. No, that's all the questions I've seen here. So I appreciate you taking the time today, Ricky. Ricky's contact information as well as some of his upcoming workshops are on here. Contact information is in small font on all 3 of those slides, it looks like. So please feel free to reach out to Ricky via email, myself or Ricky on Slack if you have any follow-up questions. And again, this recording will become available tomorrow.
And I'll send you a copy of the slides too here shortly.
Yeah,
so you can send them the slides.
Awesome.
All right. Sounds good.
All right. Thank you, everyone, for joining. Thank you, Ricky.
Thank
and I'll see
you
you all next
Bye.
time. Bye-bye.